All right, so I want to talk about the configuration of the winding. Uh, um, the configuration of the winding in the context of the rotating magnetic field of the generator. So, considering the placement of the 12 electromagnets, here they are, like this, at the midpoints of a cube, whose center is there, which is the center of the core. You can see here that if we have the winding, one segment going down like that, rotating 90 degrees, coming up there, down, and so on, as I showed before, that after one 360 rotation, you get a segment. Oh, no, that's not right. You get a segment, still a down segment, progressed until finally, after 90 degrees of these progressions, you'll get a down segment and an up segment passing through the same magnetic field. Now, what this means is that because you've got one component of the winding passing through a north field and another component passing through a south field in the opposite direction, there will be an inductive effect. So that the effective inductive loop there, we'll call it that, extends over the length required to rotate this segment through 90 degrees of incremental progression to imply this one, right? And the same thing is going on at each point. So that's the first thing. There will be what you can call a greater loop. This is a continuous winding. So we have to try and imagine what's happening inside of that loop. First of all, you have components like this, simple segments like that, where one component is one part of the winding is passing through a north field, and further along here passing through a south field. So that implies that there'll be some sort of inductive effect along the winding between those 2 points. Similarly, if you have this loop there passing through a south field there, then up here we've rotated and the same little segment, the second part of that, passing through a north field in the same direction. So that implies that there's an inductive effect along here, analogous to an ordinary loop passing through in a two-pole scenario like that. So what what you can further what you'll also notice here is that each segment of winding around the core abuts, is adjacent to some component of the core field, all of them. So with where that point of abutment is incrementally progressive, effectively along the winding. So bearing that in mind and allowing that there are these three basic sorts of inductive component, you can imagine that within this greater loop that I mentioned, there are minor components which integrate, which maybe integrate within a greater loop to create an effect, to induce a voltage, in other words. However, in order to imagine this effect, in order to you have to imagine first that um, you have to imagine first that because of by virtue of the continuity, the ubiquity of the magnetic field operating, that first of all that there are oblique components of inductance as the winding progresses through and as it moves through this field being driven around there by the rotating magnetic field, that and that these oblique components, um, the obliquity of these components, it, undergoes a graduated transition along the winding. So um, that you can imagine that they're over the period of during the effect of rotation, there will be a rotation in the actual obliquity of the whatever resultant is induced in the copper winding. Now, in order to entertain this in orthodox terms, you'd have to think about something like electron L, the orbital momentum of electrons. So in the case of copper, you're talking about the 3D, particularly about the 3D subshell, the D10, S1, D10, the five orbitals of the D shell with that S1, 4S1 peculiarity. So statistically, you would imagine that in orthodox terms, there are other ways to look at this, but in orthodox terms, that statistically the electron would, in this case where there are oblique components, that the electron is spending more time, there's great probability that it'll be found in one orbital or one of a pair of orbitals, one part of a pair, than another. So the mathematics of that, it's there, in quantum mechanics, the mathematics is limited to perhaps to a description of strictly of orbitals, but they follow the mathematics. If this effect could be demonstrated, the mathematics is there to describe it if necessary. The reason that you can entertain the idea of oblique components is because of the continuous magnetic field operating. So in the ordinary case of a loop passing through a two-pole generator, oblique components are basically noise in that context. But here, you're forcing these components. You're forcing the orbital configuration of excuse me, of within given you've got a lattice of copper atoms, and you're forcing the electron configuration in those atoms to shift in a particular way. And the same thing with free electrons. So even though you might imagine them as sheep in a paddock being herded around or whatever, they're not. They're obeying a generalized. They're subject to the forces of a magnetic field, for example, right? So their angular. If you want to think in terms of angular momentum, then the position, the magnetic moments of the electron and so on, will respond to the magnetic field there in an orderly way, and that's the basis of the idea that that's the sense in which you can imagine oblique components actually being induced and being integrating productively to create an inductive result, a voltage in this winding. Okay, that's the general sense. That's what I'm trying to say here. Just returning to the way in which the core the core is driven. You've got the north. I've shown you before just with 4 electromagnets around there, but these 4 are replicated up here and down here. So the core will be acted on, being repelled here, for example, from this north side, will be repelled at all these points, here, here, and here. The equator, 45 degrees down and inferiorly, 45 degrees up and inferiorly. Those, when these have switched from south to north to repel this attracted here, the same thing there, south, 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 all of those will switch to north and keep driving it around. So while this is happening, these segments are passing through a dynamically changing magnetic flux, which is changing in a regularly incremental progressive way. And that will, that will result in this is the idea of the experiment, to show that this will result in some sort of current being induced, some voltage being induced in the winding. So what the form of that current is the subject of the experiment. So what I imagine is going on, just thinking about this this progressive obliquity, so that if you imagine it going gradually rotating like to the point where it flips over somehow and then continues, right? What I can imagine here is that you've got some sort of a voltage wave, if you want to think of it that way, a magnetic field as well associated with that, taking into account the effects of Lenz's law and so on, which spirals along the winding in a rifling sort of way, as it were. So there's not really any to and fro oscillation backwards and forwards we think of ordinary alternating current in a traditional scenario. It's more any alternation going on will essentially be in the radial or lateral components of the winding. So that's how I imagine. How this would be seen by a measuring device such as a voltmeter, I'm not sure. Perhaps as a DC even, but or even on an oscilloscope, it will be hard to say what you'll see. But that's what I imagine is happening. All right, we'll just have a little pause there. I think. So this spiraling effect, if it exists, would be, you can imagine this wave being driven along by virtue of driven by the rotating magnetic field, displaced into the winding and driven along like that. So compared to the backwards, forwards sort of rowboat, with respect to the efficiency of the conductance going on here, the conductivity here, the efficiency would be something like, what I imagine, the difference between the ordinary loop, 2-pole loop scenario of a rowboat sort of effect, or in if you improve that with a triple phase system, you might get a paddle wheel. This is a propeller going on. This is introducing the efficiency of a propeller, to make an analogy with classical mechanics for the propulsion of a boat. That's what you're doing. You're introducing a propeller or a sail, if you want to imagine that this helical form here, this continuous, where, by the way, every point on this sphero-helix here, on the opposite point, there's a diameter. So all of those radial components to the center of the sphere are passed through the plane of the magnetic core, so the solid plane of it, and they're all diameters. So you've got a diameter going like this all the way, rotating 90 degrees. So it's a perfect propeller So this part of it is the quarter circle is akin to a sail. It's on a sailboat, and it's the same effect. Has the same effect as a repeller. Same effect, translating longitudinal components into rotatory um, resultant in this case. And you can imagine that in the sail the same way. It's all along the sail, those longitudinal components are all translating most efficiently into the propulsion of the boat in a given direction. All right, so that's how I imagine it to be. Whether that's so, I don't know. We'll see. Depends on the switch. Depends on somebody being able to make this H bridge switch for me, because I can't do it.